All right. So, guys, I think it's good to get going, because otherwise we may not be able to finish the topic. Plus, you guys need a weekend as well, I guess. I sense it because you have need for socializing. At least that's my perception here. Right, what was this class again? Right, graphics. No, mobile development. That's right. So last week we talked about, oh no, Marius talked about views, right? So what else did you talk about yesterday?
UI, padding, XML, mobility.
Mobility, right, was one of the topics, more like a high-level topic. So it was more like a history lesson. That's good, yes. So it's sometimes good to look into back into your discipline and get a good understanding. And last week we talked about what?
Storage.
Yeah, exactly. Favorite topic, yeah, storage. But there was a good point about, you know, maintaining persistence of storage over time. Like, you know, keeping your schema alive or extending your schema depending on changes, right? So it's different versions that Marius made as well. So good point there. Cool, we had different forms of storage. What were the forms of storage that Android provides?
SQLite.
Yep. What else?
Local file storage,
yeah,
and storage on SD cards.
That's right. What else? Two more things I could think about. But if you don't remember, I repeat the lecture, you know? So that's my threat here. So please.
The shared preferences.
Yes, that's right, right? Shared preferences. So where you don't need to deal with anything, in fact, right? So you just call them and wherever they're stored, who bothers anyway. I mean, technically they're on the internal storage, but you actually don't interact with it. So you don't need to deal with permissions there. That's good. And the last one, probably the most important one. At least the most annoying one. When you implement it, you will notice when you get there. What else? There was one more concept. That was the most abstract concept in terms of storage that Android offers.
Asset manager?
No, yeah, it was like a sub-concept. That's not what I'm looking for. Yeah, that's right. So if you ship something assets with your application, they use the asset manager to manage those. But storage, when we talk about persistence, it usually means that we change something and, you know, keeps that state over time and stuff like that. So, what was the last? Yep, please.
Content provider.
That's right. Right. So content providers was one of the core concepts there. And what was special about content providers? How does it do storage?
You don't have to know.
Exactly, right? So no one has any idea how they do it, right? So some people will probably do, I guess, you know, if you look into the source code, you get an idea, but technically you shouldn't, right? Because it's basically just the API uniform interface that you guys can use, or in fact anyone can use, in order to inject or retrieve data, right? So, and the reason why I'm bringing this up right now is that content providers are the second, one of the four important application components that we're dealing with in Android, apart from activities, services and broadcast receivers. So and today we're talking a bit more about services to motivate why we want to use them and when we would want to use them. But one of the other aspects that we talked about repeatedly, and that's very important for your assignments, since we're getting closer to you guys doing actually your labs and fundamentally eventually the assignments, is that I/O operation and network operation is supposedly happening in the background, right? So if anytime we interact with the file system, for example, for persistence reasons or whatever else, but also a network, we have to use some sort of mechanism to do it in the background. Any of you who's doing Java, do you know a concept that you use there? You guys did Java all right? No, half of you roughly, right? The ones that were I'm 30 year did Java, I assume? Please say yes.
Yeah.
Good. So thank you. So what's the concept in Java you would use? to deal with background activities, if you like. Threads, right? So you guys played with threads in Java? Cool. So you're comfortable with the threading framework. And cool. And that's fundamentally the way you do it. Basically, you have the main thread, and you spawn off a secondary thread, that worker thread, that does something else, right? So for example, write it to your disk and eventually give feedback or not. It's up to you how you deal with this, but it won't block you UI. You can continue pressing buttons and do other stuff, right? So yeah, so threading is one important aspect. And in Android, the equivalent concept is AsyncTasks. And it's fundamentally the same thing. The main difference is there that asynchronous tasks are modeled in a way, they're built on the top of the conventional Java threading framework, but since Android assumes some sort of UI interaction basically, they are built around the idea of actually being able to give feedback. Right? So which is not the case for threads if you don't model it explicitly, right? So it's up to you very much. And once we did this, we look into services as well as one of the most important components in addition to that one. So again, one of the key things if you're modeling or if you are actually writing Android code is to avoid the main thread for anything that lasts longer than, that goes into realm of seconds. You don't want to have that in your main thread, and that means you don't want to have it in your activity basically. But instead you want to have some sort of asynchronous task that you launch. That runs pretty much parallel to your main thread and is somewhat independent as well. And the asynchronous task thing is special in a way because it's kind of cross-cutting. The concept can be used in any of the application components, so it's not associated only with activity or service or content providers or whatever else is there, but you probably use them with many of them. Yeah, so just bear that in mind. So it's quite a valuable concept to know about. And once you hear about this and you learn about Java or learn Java, then you see threads, you see the parallels are quite striking, I believe. So let's think about this first. So the idea is that if you do a background task, for example, you have a UI activity, you press a button and you're supposedly storing something or retrieving something, then this is the kind of activity you want to do in the background. But at the same time, you want to obviously give some feedback, right, to the user, saying, well, it actually failed, right, or it actually worked out, or your progress is as follows. Right? So, and that's precisely where we need this kind of mechanism. So anything long running, typically I/O. So multi-threading, could be that you're parallelizing some activity or operation. Of course, you can use them for that purpose, like compression or things like that. Or most commonly I/O in our case. In fact, you will get an exception on Android if you try to do that kind of stuff on the main thread. And the idea is as follows. Basically, you create an asynchronous task, and it has it's basically an interface that you need to implement, including a few methods such as on pre-execute, on progress update, and the do in background activity, and then on post execute, so which produces the result. And the idea is there, on pre-execute is executed before you actually spawning off the asynchronous task, then your activity is running in parallel and you actually give feedback, continuous feedback to the main thread. So it solves the issue of thread communication for you to some extent and gives the final return value or the result once the task is completed. So I'm trying, so let's see how I first of all send my best wishes to the stream, because they may suffer now, because I'm trying to use Android Studio on my machine and do streaming at the same time, and I recall that it usually doesn't work out quite well. If anybody is monitoring the stream, let me know if things went sideways already. Yep.
Can you please turn off the lights?
That's a good idea. Let's try that. Oh. So I just press some button. If something happens, let me know. Exactly along those lines. Yeah.
Nice feedback. Yeah.
Almost. Cool. That's roughly right. Cool. Nearly cinematic atmosphere. There you go. Better?
No.
No? Full on?
Last one.
Oh, you're insistent. Oh, that's
better.
Alright, we leave it at this? Cool. Everybody can read something?
Yes.
Good. Cool. So what I did here, I did this in advance, was just setting up a simple activity, right? Because that's usually where Gradle behaves the worst. So I did this in advance. But let's just model a simple, model is the wrong term here, but mimic a simple idea that we do something in the background. So Okay, we have the beautiful onCreate as we usually have. Yeah. So, and the idea is there that we have some sort of class, some private class, so a class that lives inside, that in this case, the activity, how do we call it? Let's call it time waster class. Because, time waster task if you want. And it needs to extend task because it extends the asynchronous task, so you want to have it equivalent. Extends the async tasks abstract class. So where's my, there you go. Right, so in the asynchronous task, it has a few type parameters that it takes. One of them is what's the type of input you are actually providing to the asynchronous task. What's the type for any output you produce, intermediate output you produce, and the result output you produce. So you need to indicate this. So in this case, we have an integer as input. We're expecting feedback in form of an integer, and we're expecting a result in that form as well. So it's a classic use of generics in Java. You can obviously return any object of any complexity. So it needs to be an object type. It can't be a primitive type. So it can't be something like int or something like that. That doesn't work with generics in Java. So if you write this one, you get an error. Cool. All right. So what does it say? Well, probably I need to import something, and since I'm too lazy to figure out where it actually exists, unless I got a typo here, which is the case, we live with that one. And we need to import it as well. There you go. So yeah, it's AsyncTasks of Android OS. Cool. Now it complains. Obviously, we need to implement some methods that are available. And the only one that we actually need to implement is the do in background. That's where the actual task is done. So how it technically works, once this AsyncTask instance is created and actually activated, it performs anything that's in the do in background activity and returns the final result ultimately. If you want to do multiple tasks in there, you are responsible for creating your loops or whatever else you need to keep it, doing other stuff in the secondary thread. So in addition to those ones, you have some other methods that you can implement. For example, on pre-execute, you can do some magic. You can provide the system with a progress update. We'll see how that goes. Yeah, so here's some stuff we could do. So now we need to do some meaningful input. Right. Okay, let's just take an integer as input, do some waiting time, because that's usually the most boring standard example that you can provide, but it's also the most intuitive and most generic one. So you can reuse it for any of the purpose you find. So if we have a counted integer, a counted for loop, we take some sort of input. By the way, that's I'll just get to the notation in a second. Keyword is a bit, what am I doing? I'm missing a semicolon here. There you go. So if you notice here on progress updates, actually I want to do it in background, not on progress update. That's a waste of time. Hang on, this one here, do it in background. You notice here that you have this integer ... notation that basically means it takes an arbitrary number of parameters of type integer, right? So it's open-ended. You can have integer 1, 2, 3, 4, 5, 6, 7, 8, and so on. And it returns it internally. It's accessible as an array. So in this case, I assume that, well, that's dangerous. I'm not testing for the length of the array, so which is evil. But let's assume you guys know that and debunk that issue already. So then you can basically operate based on this input. So let's call them integers because that works. Cool. And let's do some stuff. Let's, for example, sleep for 1 second. So that the unit is milliseconds. And since it's yet another thread that we're actually starting, oh, sorry, it's not another thread, but we are actually controlling the thread execution. So that usually means if something gets interrupted by the JVM, or worse, indirectly by the operating system, what are we doing with the, how are we reacting to this case? Because that's outside of our control. So we need to have a exception. We need to catch the interrupted exception accordingly, and print a stack trace. That will be basically forced upon you. You don't need to worry about this on your part. Cool. So, all right, we do this each round. Yeah, we want to have something meaningful, I guess. So let's return 0 here. Let's model a UI first, so we get actually some meaningful output. It makes more sense then. Oh god. So much about the reaction of my system to user input. There you go, brilliant. I like it. That's interactivity. So, and there's two things. So one of them, obviously, you want to have a button that we can use to initiate something. What would be the world without a button? So let's fix that somehow, so we don't have dramas here. But more importantly, you also want to give the user some sort of that's not what I want to do. Sorry. We want to give the user some progress update. So you have those famous progress bars, for example, that you can pull in, all those spinning things and whatever else. There you go. Yeah, fix that somehow. So right now you observe my artistic skills, which are next to non-existing, and that won't change anymore, I think. But nevertheless, we'll get a reasonably somewhat, some output here going. Let's pull you down. Cool. All right, cool. This thing here is a progress bar. So let's briefly identify what we have. The ID is progress bar, so we can access it from within. Let's make it. There was a mistake. And we obviously have the button. The button has the identifier button, right? So we can access them using r.id button. So now we have actually something we can work with. So progress bars, unless initialized else, otherwise they will show their progress on the value scale from 0 to 100, like in terms of percent if you want. But you can parameterize them differently if you want. We're not doing that right now because it's, whatever. So it's not really dramatic. But what we need to do here is we actually need to get access to the progress bar in the first place. So in easiest way is, can we just use it's a bit inefficient, but we'll find it. Find ID by view, r.id dot, what is the thing again? Progress bar. Cool. Probably to cast that, otherwise it's not going to happen. And then set progress, so, and set the progress to whatever input we get here. So, cool. So now we get an error because by default find view by ID will return any type basically. It's not it doesn't know what type the input element is of, so we need to cast it into progress bar and need to import that. So we cool. Sweet. So take any input you get from the onProgress update and publish it to the progress bar entity, and set it to the current value. So the only thing we need to deal with is that we ensure that we're modeling progress in steps somewhere between 0 and 100, which probably is about reasonably what we should do anyway. So what you can do there then is basically, so we are counting, depending on the input, we're iterating it for a given number of times and wait 1 second each. And since we want to give the user some feedback, we publish the process as well. So so this code is definitely not super hardened. That's something you need to fix later. And just I+1 will do. It's a bit ad hoc, but we get there. So as long as you see some output. Cool, what else do we need? That's the progress update we want to do. And, we want to make the Let's see. Let's compile this thing, how it goes. Right, we should create a new instance of the emulator. Ah, no, there you go. So now Gradle is doing his job. Is anyone watching the stream? No, it's good. It must be terribly slow.
Just 1 second. I mean, the stream is going good so far, but in a few seconds the emulator will come up.
I hope it's up already. Anyway.
It's working.
Yeah, cool. That's cool. Still building. The hard part is still about to come. We'll see. So it should come up, and then we'll see if we get anything from the system. While we're waiting, that's it. Can't. God. Please, emulator, stay with me. Yes, but okay, I forgot something. What did I forget? It won't work. It will look good, but it won't work. Why?
You haven't added the view as parameter?
I didn't get that. Sorry.
Maybe I'm mistaken, but I thought you would have to have view as parameter for the function that is supposed to get button and the progress bar.
I think we're on the right track here. I forgot to attach any action to the button actually. So whenever I see the button, we can press it, and that's really beautiful. And sounds Trumpian, beautiful. Anyway, but we probably need to get that right first. All right, so we need to get the button. So the button was ID button, which is not, again, not super creative, but since we only have one of them, we probably survive. Casting again. Yeah, do that, please. Thank you. And we want to have an on-click listener, new on-click listener. And whenever we press the button, we want to do some stuff. And so that's basically the only thing that we actually need to do is to say create a new instance of the our async task. In this case, we call it creatively time waster task, and execute it. So cool. We said we want to have some input value. This is 10. Note, if you don't want input, if you want to run an asynchronous task in the background entirely, you don't have any input, you can set the input values or output, whatever, to void. In this case, you don't need to specify anything. You just say, new instance of class.execute, and then it will run, right? So if you want to do something that doesn't require explicit user input. Cool. Is there anything else I wanted to do? Oh yeah, we can obviously do some stuff on post update as well. Post execute. We could actually make a toast and tell that it's actually complete. That is usually quite helpful. Activity, this to be explicit, and we want to have a toast completed. The toast length should be, I think that's the length parameter, but shouldn't have done that. Go away. So toast dot long. We want for long showing toast, and the most important thing dot show. I always forget to do that. Therefore, mind that if you're creating a toast instance, always call dot show. If you don't see anything, and you think you should see anything. So it's kind of confusing. So cool.
Toast input.
Sorry, did I forget something?
No.
Did we talk about toast before? No.
No. What's a toast entry?
Toast is something that pops up and vanishes afterwards. That's like the computer science representation. No, obviously not. It's basically a small, it's a good, what is it actually? Not notification, they're on
Alert.
top.
Pop-up?
Alert, yeah, not pop-up. Alert is probably the thing. It's like a more alert that is there for 1 or 2 seconds and it's gone again. We'll see, hopefully.
Ah, okay.
Yeah, so that's referred to as toast in Android world. Sorry for that. I took that too implicitly. So I'm updating the emulator now with my hopefully correct version. So, oh, let's add a word in there. That's creative. It's still installing the APK. It's yeah, cool.
And then
Actually,
it died.
so that's right. No, it didn't die. So now we're getting somewhere here. All right, it's actually doing stuff. So you have a mini progress bar. Should remove the hello world. It's a bit ugly, isn't it? But the function is ultimately there. So and then yes, completed. There you go. That's the toast.
Ah, cool.
Yeah, you can make them short, long, whatever else. The key thing is again is the .show. This is what people most likely forget. You have a toast and your one is not showing up. You need to call .show on it anyway. So but that's the entire stuff here, right? So as soon as you do that, just to do the counter example, let's see what Android actually says when we do that bluntly in the main thread. In fact, we don't need that even. Just try to sleep for, let's try to sleep for like, I don't know, 5 seconds or something like that. See what's happening. Looks good. Indentation obviously not good, so since we are proper, we get that right first and then see how that looks like. Ah, there you go. Well, what does it say? Compiler, that was not explicit enough. Class interface. What did I do wrong? New on-click listener. I think this is too much. Don't need this one. So, see if it's clever enough. It may actually fail doing compilation. No, it doesn't. Okay, that's scary. Good. Right, let's see what it does. Still looks. Cool. It does. I'm not sure if it really picked it up here. What's supposed to happen, but. Oh, hang on. To put this into the button. Get rid of that. So we just sleep 10 seconds in there. So no error here so far, that's pretty okay. There you go. Right. So it actually abandoned the execution. The application may be doing too much work on its main thread. So, right, there you go. So you get some feedback like that. So in this case, it doesn't throw an exception. I would have wanted to see an exception rather, but it actually indicates precisely that it's measuring really. Oops, hang on, what's happening here? So actually, for creating the activity, usually spends about 600 milliseconds, right? Less than a second to actually get something going. But right now, because I introduced a it actually abandoned the execution because I had 10 seconds set up here. So basically it's not doing anything because you're doing too much on the main thread. That said, no much feedback. I would have preferred a bit more feedback. But you get the gist anyway. So you need to do it in the background. So be mindful for those kind of errors. If you see nothing is happening or you get an exception, most likely you need to use an asynchronous task. Cool. Did everyone get the gist of that? Or has anyone totally lost what happened here and what I talked about in the first place? And it may just be me, tell me. Yeah?
Yes.
What was it? Yes? Totally confused and lost?
Yes.
Yeah? Okay.
What happens on line 57 looks really awkward.
57?
Yeah,
Yep.
the magic numbers in
All right, I'm just trying to publish the progress to the progress bar. Yep. So it just consumes the progress, and then on progress update, it just, sorry. So doing in background, I'm publishing the progress. The progress is injected here on progress update. It's like a event handler here, and
I just don't get the math.
Okay. So I want to progress per iteration unit the progress bar from 0 to 1. So right, assuming I get a
okay, it should be between 0 and 1.
Between 0 and 1, what? No, 0 and 100. Sorry, yeah. Right, 100 divided by the number of, so this is the increment, 100 divided by the input is 10, so increment 10 times the number of iterations, right? So iteration 0 plus 1 is first iteration, 10, 20, 30, 40, 50, that makes sense?
Oh.
You see what I mean? Yeah, whatever. I mean, you find a better way of representing it, but you get the gist? At least was the intent.
What's in integer 0?
Ah, right, okay. Right. So,
is it just the number 0?
No, here, before I introduce this threading stuff, let me remove that one. I instantiated the time waster task, right? The whole asynchronous task, cool. And I pass it a parameter, an input value of 10, which is of the type integer. So it's a 10. I could pass multiple of them because the do in background method actually takes an arbitrary number of parameters of type integer.
Oh, so it's the first argument.
I'm just taking the first element there. Yes, but if you want to do it right, you check carefully whether there's actually an element in there. So you check on integer.length, right? Integer array.length. But yeah, that's the essence.
Okay.
Yeah, it's good. So, but the neat part about the async task, you can get feedback or progress feedback, and that's quite cool compared to threading in Java otherwise, which generally doesn't have that built in out of the box. And it's quite low threshold here. Note that the progress bar, if you want to use it, is a UI element, so you don't you directly bind it to the UI element, or if you want to instantiate it from code, as talked about yesterday, is obviously an option as well. But that's roughly it. Does that make sense somewhat now, ish? Yeah. No, it's still a valid answer.
Yeah.
Yeah, please.
How is the cost of creating threads in Android compared to Java?
Well, technically the asynchronous task implementation uses thread pools, so they already have instantiated threads, so it's just a matter of putting work towards them. I think by default they have about 128 idling threads in their thread pool that were possibly used or reused, so the penalty is very, very low. So it's precisely, you're right, precisely for that reason. In fact, many of the a lot of the internal functionality in Android uses AsyncTasks anyway, because that's the, let's say, lowest common denominator from Java side to actually have concurrent activity. So the impact is very low. It's a lot lower than compared to creating new application components. Yeah, so that's the key idea. So it's by default the way to go if you want to do anything in the background asynchronous tasks. So you shouldn't have any challenges, well, even with large numbers, or if you want to do any parallel activity. So, but I think this sequence diagram-ish here, that clarifies somewhat what's happening, right? So on pre-execute, you initialize something that you probably need, then you do the background activity, for example, the iteration and waiting, or nothingness, or downloading JSON, or I don't know, anything but, yeah, anything that's somewhat time involving. Publish the progress if you want. The progress would be published then on in UI, on the main thread representation, and then post result you get something back or not, and you do stuff with it. So that's the key idea. It's quite straightforward. So async tasks are okay, they have limitations. Some of them are here lined out. They obviously don't have autonomy. They're not an application component in their own right. Yeah? So they need to be started from within some sort of Android application component, being it service, didn't talk about it yet, content provider, activity, or a broadcast receiver, which we didn't talk about either. But for example, for content providers, if you storing content on the web, for example, you would need to do that as well. Use some sort of asynchronous task to manage that one. But they don't have any own resources per se, and they're not really persistent. Once they're dying, all their members are gone, right? The instance is discarded, garbage collected. So they can, however, access the resources of the parent application component, right? So they could access the activities, shared preferences, or any internal storage or external storage that's associated with the activity. Yeah. And yeah, here, that's the thread pool implementation that's it builds on. Yes. So if you want to have a container service or a container for tasks that are a bit more long running and persistent in a sense, no, long running is the term here, persistent is a bit off. Then you need something else, because asynchronous tasks, if they live, for example, in activity, they die with the activity. If you're doing a download and you're clicking on your home button, right, so your back button, then your download is gone. Right, so it's not continuing there because it will return to the activity. However, the activity will die, right? Potentially even being garbage collected, but at least not being active anymore. So you would not receive, the result of the execution. So it's tied to the application component. But here services come into play, which is like now the third application component that we are dealing with, which is basically the equivalent to activities but in the background. No user interface. But made for longer running interactions, direct or indirect with the user. But we get to that in a second. They can control their own runtime, so they have a certain autonomy. Again, remember, asynchronous tasks can only kill themselves basically, but they can't really have a more sophisticated way of controlling their runtime, or at least not as sophisticated as, for example, activities can. But we have different types of services because they obviously serve different purposes. A classical service that you probably most commonly use is like a media player, right? So which kind of runs in the background. You're still using Google Chrome or whatever else to browse the web or do something else, which is the activity in your on your phone. But you still want to have your media player run in the background, right? So this would be facilitated via a service. If the service has some notification, meaning there you go. If something pops up here on top, right, for example, telling you playing, I don't know, Taylor Swift's latest album, I don't know, whatever else, then it would be considered a foreground service, because it's not a service that can be discarded at discretion of the operating system because of relevance to the user, right? So if you, for example, have your a download service that's running in the background and downloading latest podcast is supposed to be your media service that's playing your current music you want to listen to, you obviously have a clear priority there. So if the downloads are getting disrupted because your phone doesn't have the juice anymore, that's fine, but your media playing should still go on, right? So it should be only in emergencies that this service would be killed. Because the idea is there that on Android as operating system now, not so much as programming environment, but as an operating system, controls the all application components, right? It has full control about over discarding them, even if you're not explicitly finishing them, for example, meaning not discarding them for memory. Android will cache them and eventually remove them at its discretion. But you can indicate to some extent, what the priorities are in that particular context. So, and foreground services are one of them. So, so it's not, you can't really suggest that, for example, activities have higher priorities than services. It really depends on their use cases. We'll see that in more details in a second. So then you have obviously background services like you're used to on your conventional operating systems, like, for example, I don't know, update services, backup services, synchronization services on Mac OS or Windows or whatever else. They would run in the background and pretty much live with the operating system, have autonomy to an extent that they may be started by other application components or based on external events, such as connecting to the internet, may start Google Play services or something like that. So they check actually for the updates and it suddenly pops up, say, hey, do you want to update your device? That's not something that required you to do any sort of interaction, but that's precisely what's happening with services there, that they can listen to other events. And those are pretty much detached from your application use, so that's where Android is a fully fledged operating system in a classical sense. And then we have bound services. And bound services are services that pretty much serve as a, yeah, you can think about it as an, inter-process communication tool, meaning you can actually have multiple activities use the same service and use that to do long-running tasks. Yeah. So access shared memory. So use the service to access the content provider to do some stuff, or use the service to access the internet. And as long as the any application component is bound to that particular service, the service will continue to do its operation. And as soon as all of them disconnect, then this server dies as well. Service dies as well, right? So the idea is there. It's built like a master. If you think about a LAN game environment, you have kind of a master server, right? And all the clients connecting to it. And that's pretty much the function of the bound service as well. It will just wait for its client to actually connect. And if none of them exists, it will die. That said, if there's a bind request from a client, it will create a new instance of that bound service as well. But similar to applications, the services can control their resources, right? So when a service is shut down, here it's quite probably quite straightforward. Here we have a similar life cycle model as you guys saw before for activities. I'm not sure how visible that is, but we'll get the gist here. It's a bit simpler. In the default case, in the normal unbound service, the one on the left side, we see when the service is started, the onCreate method is run. The onStart command is run afterwards. We'll talk about this in a second. And then the service is running and may or may not destroy itself, or may be destroyed by external calls to stop service. We'll see that in a second. And when that happens, the onDestroy method is run. So it's slightly less complex than the activity one, because there's less reuse of services, but still it can control its resource and clean up properly if needed. The main difference for the bound service, meaning the one that actually waits for clients to connect, so it depends on clients to actually live, has this on-bind and on-unbind facility. So it can actually do additional activities at that time. For example, you want to destroy your service if there's only 2 bound clients left because you need to have 3 to get something done at least. You could model that as well. So it's not hard and fast that the semantics can still be encoded by yourself, so you can decide whatever happens here on bind and unbind. Yep.
So are these bound services something you create to manage your threads or your asynchronous tasks, or is this something the OS does?
Right. So well, depends on if you have the operating system generates the services, but if you want to do multiple parallel tasks, you would still need to use asynchronous tasks in addition. But per se, I think that's what you want to get at. If I write now a service and an application, I want to deal with them, interact with them, do I need to use asynchronous tasks per se?
Oh no, so no. I meant services. I didn't mean to say asynchronous tasks. I mean, I meant.
I may have gotten it wrong.
Is the bound service something that you do to manage your services, or is it something the OS does to manage your services?
Right, okay. So no, you need to implement it. It gives you, similar to the activity, it's or like the content provider, it's like an abstract class that you get, right? So, and you need to extend it, and then you implement the corresponding functionality. And that's precisely the same here. So you need to extend service, and then you implement the methods or not, and then do your stuff, basically. The only difference is there, you don't need to worry as much about user, well, you don't worry at all nearly about user interaction, because that's activity problems. With a few exceptions, of course. For example, you could, for example, show toasts from a service as well, so that's possible. But having a, access a button, things like that, is not part of the model. But you could do any other, basically long-running background activity that doesn't require user interaction in those ones. Yeah, that's the idea. So, but you're also right in a sense. Doesn't the operating system do that for us as well? And that's true as well, because you obviously have used already system services, right? Or in fact, did we use system services? Not yet?
No.
Good, or not good. But from...
Preference manager.
What?
Status preference manager. Isn't that a system service?
Yeah.
No.
Did we use it? That's a good question. I actually don't know if it's modeled as a system service, because the default way of accessing system services, you get a system service. We may have done so, I can't recall right now. But just to show you the API briefly, the idea is if we have a in our main activity, let's forget about our asynchronous task here. Let's just be after the setting of the display. From the context, you will always be able to access get system services, and that's quite powerful. And then you can just browse the available system services that are provided. You remember this Android framework schema where we had the services on the second level and the applications on the first level?
Yes.
Yeah, and that's the second layer that you're basically accessing there. I'll just bring it up again because I think it's quite helpful to have that handy and provide. That thing here, right? So so on the top level you have the application, the activities. They're equivalent to what you are writing, right? So the applications, and below that system services that are provided by you or by Android itself. Can be content providers or some managers or whatever else, and they just use libraries in the background to facilitate other functionality, such as I don't know, accessing location information and stuff. Then you can use functionality, for example, access all the active networks that are currently, the system is currently connected to. Could be mobile networks or whatever else. So those are fundamentally services backed by services as well. And we talk more about them as well. But obviously the idea is that you implement them yourself on the fly. I'll just show you an example for a service. I'll probably not go into depth in developing one, but here's a simple service example. Yeah, let's do that one. That would work. Right. So in this particular example, we have a service and an activity, quite straightforward. Here you see an activity, and upon pressing a button in, upon pressing a button start service, supposedly, it creates an intent that has the context of this activity. So the intent says, okay, I'm the source of whatever is happening here, and I'm calling this intent on the hello service class, which is basically a service implementation here. So it extends service, so a different application component, and then you can just call start service with the intent. So the action is encoded here in the method. It says, for this intent, start the service that's associated with this. Yeah? If that one here is not a service, then this call will complain. So, and then this is basically an example service implementation. Hang on. And you can pretty much do anything you want here. You have the onCreate method that you can do, for example, to set some flag or whatever else, and then the onStart command that is called when you receive an intent. Like, for example, right now, the start command was received from the intent from the hello activity. And then you can do something in the background. And again, here, the creativity didn't reach very far, so it's again about threading and sleeping for a given number of rounds, but you could do anything in there, right? So access remote web resources, download RSS feeds, or do anything that's somewhat bit more involving here as well. In fact, this is a nice example where it actually uses a conventional thread, a conventional Java thread. That's how it's done in Java. Only downside here is that you have no feedback mechanism, right? At least not out of the box. You would need to model yourself. That's how you do it in Java. Create a new thread with implementation of a runnable. A runnable has a run method and it executes it once. So whatever you do here, and then you call start on the thread and it will just run the thread. That's it. So the only thing you need to provide in the service, in contrast to activities, when onStart is run, you need to provide a return value. And that's actually a constant, an int constant. And that gives the system an indication of how you want the service to be treated when resources are running out, when resources get scarce. So we just returned, for example, service.start sticky. And that just means keep the service running as much as possible. If the service needs to be killed because we're running out of resources, restart it as soon as you can, right? As soon as you have available resources. If you have not sticky, it means, yeah, whatever, service is dead, good luck to me, and we'll try it again another time. But we don't require the system to restart the service. And the third option is start by redelivering the intent. So basically it means restart the service the same way it was started originally. So those are the three ways of dealing with this. So before you guys all fall asleep, because the subtle minority is starting to do so, I give you 7 minutes of break until 1:15. Is that sufficient?
Sure.
Or do you prefer half an hour break? Yes? Okay. Interesting. No, cool. Yeah, let's continue then. So, yeah.